What if we say there is someone that is protecting you throughout every step? You can't see it, but it is there, protecting you from harmful space radiation and preventing our atmosphere from being stripped away by solar winds. It's Earth's magnetic field. The magnetic field is extremely important to sustaining life on Earth. Given the importance of the magnetic field, scientists have been trying to figure out how the field has changed throughout Earth's history. That knowledge can provide clues to understanding the future evolution of Earth, as well as the evolution of other planets in the solar system. Curious to know what scientists have discovered and how it is going to affect you and me? Then give the video a thumbs up and stay tuned till the end. Welcome to The Space Discoveries. Subscribe to the channel for every single detail about the new discoveries in the vastness of the space. Also, do not forget to hit that bell icon for new updates. That being said, let's begin. Most of the planets in our solar system, including Earth, have magnetic fields surrounding them. Magnetism is a force that is intimately related to electricity. Whenever an electric current flows, there will be an associated magnetic field in the surrounding space, or more generally, the movement of any charged particle will produce a magnetic field. Try turning your kettle on and off and see if your smartphone's compass app can detect the magnetic field generated as the current runs through the cable. These fields have a direction, which is why Earth has a north and south pole. When two magnetic fields come close to each other, they will try to align, potentially causing the physical objects causing them to move. A compass needle has a magnetic field, and so will always try to line up with Earth's field and point north. The evidence for a magnetic field was found in Hubble observations of HAT P11b. Hubble saw the planet as it transited in front of its star, as seen from Earth. Overall, 6 transits were observed in the ultraviolet light spectrum, a type of electromagnetic radiation. It is a part of the spectrum that the human eye cannot see. So how did Hubble actually detect the magnetic field? It did so by detecting carbon ions around the planet. These are charged particles that interact with magnetic fields. They form what is called a magnetosphere around the planet. Other planets in our solar system have magnetospheres, but Earth has the strongest one of all the rocky planets. Earth's magnetosphere is a vast, comet-shaped bubble, which has played a crucial role in our planet's habitability. As mentioned earlier, life on Earth initially developed and continues to be sustained under the protection of this magnetic environment. The magnetosphere shields our home planet from solar and cosmic particle radiation, as well as erosion of the atmosphere by the solar wind, the constant flow of charged particles streaming off the sun. Earth's magnetosphere is part of a dynamic, interconnected system that responds to solar, planetary, and interstellar conditions. It is generated by the convective motion of charged molten iron far below the surface in Earth's outer core. Constant bombardment by the solar wind compresses the sun-facing side of our magnetic field. The sun-facing side, or day side, extends a distance of about 6 to 10 times the radius of the Earth. The side of the magnetosphere facing away from the sun, the night side, stretches out into an immense magnetotail, which fluctuates in length and can measure hundreds of Earth radii far past the Moon's orbit at 60 Earth radii. Traveling to see the northern or southern lights has made its way into almost everyone's bucket list. But unknown to most, these beautiful displays of light are caused by dangerous cosmic rays that have been deflected by our Earth's magnetic field. On Earth, flowing liquid metal in the outer core of the planet generates electric currents. The rotation of Earth on its axis causes these electric currents to form a magnetic field which extends around the planet. So, you might be wondering, what would have happened to Earth without these magnetic fields? As we said earlier, these magnetic fields are extremely important to sustaining life on Earth. Without it, we would be exposed to high amounts of radiation from the sun, and our atmosphere would be free to leak into space. This is likely what happened to the atmosphere on Mars. As Mars doesn't have flowing liquid metal in its core, it doesn't produce the same dynamo effect. This left the planet with a very weak magnetic field, allowing for its atmosphere to be stripped away by solar winds, leaving it unhabitable. An international team of astronomers used data from the Hubble Space Telescope to discover the signature of a magnetic field in a planet outside our solar system. The finding, described in a paper in the journal Nature Astronomy, marks the first time such a feature has been seen on an exoplanet. A magnetic field best explains the observations of an extended region of charged carbon particles that surround the planet and stream away from it in a long tail. So remember the carbon ions around the planet. The carbon ions were found not only around the planet, but also in a long tail, called a magnetotail, streaming away from the planet. The phenomenon is reminiscent of a comet's tail. The average speed of the particles is an incredible 100,000 miles per hour. The tail itself is also quite long, about 1 astronomical unit, or the distance between the Earth and the Sun. Earth also has its own magneto-tail. This is the first time the signature of an exoplanet's magnetic field has been directly detected on a planet outside our solar system, said Gilda Ballester, an adjunct research professor at the University of Arizona Lunar and Planetary Laboratory and one of the paper's co-authors. A strong magnetic field on a planet like Earth can protect its atmosphere and surface from direct bombardment of the energetic particles that make up the solar wind. These processes heavily affect the evolution of life on a planet like Earth because the magnetic field shelters organisms from these energetic particles, he added. The discovery of HAT P11b's magnetosphere is a significant step toward an improved understanding of the habitability of an exoplanet. Not all planets and moons in our solar system have their own magnetic fields, and the connection between magnetic fields and a planet's habitability still needs more study, according to the researchers. Researchers led by the paper's first author, Lotfi Ben Jafel, at the Institute of Astrophysics in Paris, then used 3D computer simulations to model interactions between the planet's uppermost atmospheric regions and magnetic field with the incoming solar wind. Just like Earth's magnetic field and its immediate space environment interact with the impinging solar wind, which consists of charged particles traveling at about 900,000 miles per hour, there are interactions between HAT P11b's magnetic field and its immediate space environment with the solar wind from its host star, and those are very complex, Ballester explained. Do you know? The jury is still out on whether the Earth's magnetic field existed earlier than 3.5 billion years ago. There is no robust evidence of a magnetic field prior to 3.5 billion years ago, and even if there was a field, it will be very difficult to find evidence for it in Jack Hill's zircons, said Cal Borlina, a graduate student in MIT's Department of Earth, Atmospheric, and Planetary Sciences. It's an important result in the sense that we know what not to look for anymore. Scientists know that today the Earth's magnetic field is powered by the solidification of the planet's liquid iron core. The cooling and crystallization of the core stirs up the surrounding liquid iron, creating powerful electric currents that generate a magnetic field stretching far out into space. This magnetic field is known as the geodynamo. Multiple lines of evidence have shown that the Earth's magnetic field existed at least 3.5 billion years ago. However, the planet's core is thought to have started solidifying just 1 billion years ago, meaning that the magnetic field must have been driven by some other mechanism prior to 1 billion years ago. Pinning down exactly when the magnetic field formed could help scientists figure out what generated it to begin with. Borlina says the origin of Earth's magnetic field could also illuminate the early conditions in which Earth's first life forms took hold. In the Earth's first billion years, between 4.4 billion and 3.5 billion years, that's when life was emerging, Borlina says. Whether you have a magnetic field at that time has different implications for the environment in which life emerged on Earth. That's the motivation for our work. NASA's studies about the magnetosphere will help to better understand its role in our space environment. Such research helps unravel the fundamental physics of space, which is dominated by complex electromagnetic interactions, unlike what we experience day to day on Earth. By studying this space environment close to home, we can better understand the nature of space through the universe. What do you think? Share your opinion about it in the comment section, and if you find the video informative, then don't forget to press the like button. Subscribe our channel for more interesting and informative videos, and press the bell icon to get the notification. We'll see you in the next video.